Analysis and Design of Algorithms, Module 2. Brute Force Approaches, Exhaustive Search, Traveling Salesman Problem and Knapsack Problem. Decrease and Conquer, Insertion Sort, Topological Sorting. Divide and Conquer, Merge Sort, Quick Sort, Binary Tree Traversals. Divide and Conquer, Merge Sort, Quick Sort, Binary Tree Traversals. Multiplications of large integers and Stussens matrix multiplication. General method. Divide and conquer strategy, splitting the inputs into distinct subsets, yielding k subproblems 1 less than k less than or equal to n. Subproblems solve combine subsolutions into a solution of whole. Often the subproblems resulting from a divide and conquer design are the same as the original problem. Using recursive algorithms, subproblems are generated that are small enough to be solved without splitting or produced. Control abstraction for divide and conquer. Type D and C P. Problem to be solved. If small of p, return s of p. Is Boolean valued function that determines whether the input size is small enough that the answer can be computed without splitting. Else, divide p into smaller instances p1, p2, pk, k greater than or equal to 1. Apply d and c to each these subproblems. Return combined value of d and c of p1, d and c of p2 till pk. Function that determines solution to p using the solutions to the k subproblems. If the size of p is n, the size of k's subproblems are n1, n2 to nk. Computing the time of d and c is described by the recurrence relation. D of n is g of n if n is small, otherwise d of n1 plus d of n2 plus d of nk plus function f of n. T of n is time for d and c on any input of size n. G of n is time to compute the answer directly for small inputs. Time for dividing p and combining the solution to subproblems. Recurrence relation equation for divide and conquer. The complexity of many divide and conquer algorithm is given by recurrences of the form t of n is t of 1, n equals to 1. A t of n by b plus f of n, n greater than 1. A comma b known constants, t of 1 known, n is a power of p, n equals to b of b power k. Method for solving the recurrence relation called substitution method. Recurrence relation method repeatedly make the substitution for each occurrences. Now divide a problem of size n into size of n by b, taking f of n time to divide and combine. T of n equals to a t of n by b plus f of n. Time for size n, number of subproblems, time for size n by b, and then time required for divide the problem into subproblems. Order of growth of t of n depends on the constants a and b. Order of growth of function f of n. T of n equals to a t of n by b plus f of n. A is greater than or equal to 1, b is greater than or equal to 2. Assume n equals to b power k, where k is 1, 2 something. T of b power k is equal to a t of b power k by b plus f of b power k, a t of b power k minus 1 plus f of b power k. Substitute k by k minus 1, a t of b power k minus 2 plus b power k minus 1 plus f of b power k. Substitute this. Substituting this becomes f of b power k minus 1, that is b a t of b power k minus 1 equals to t of b power k minus 2 plus f of k minus 1 f of b power k. Then again if same thing along with this, continuing it can also be written as a power k t of 1 it goes till a power b power k minus k plus a power k minus 1 f of b1 a power k minus 2 f of b square plus a power 0 f of b power k. A power k t of 1 plus a power k minus 1 f of b plus a power k minus 2 f of b square plus a 0 f of bk, also written as a power k t of 1 a power k by a f of b power k by a square a power k common t of 1 plus f of b by a f of b square by a square, that is nothing but t of 1 plus sigma j1 j equals to 1 to k f of b power j. B property of logarithmic, a power k can be written as power log bx log bk, then x log a to the base b, a power k is log bn, a power log bn, that is equal to n power log ba. Rewriting the equation, n power log ba n power log ba t of 1 f of b power j by a power j. T of n equals to a t power n by b plus f of n equals to 2b equals to 2, t of 1 equals to 2, f of n equals to n. T of n equals to 2 t of n by 2 plus n. Why? Because here we have got considering an example 2t of n by 2 plus n. Now 2t of n by 4 plus n by 2 plus n by 2. N will be divided by 2. Then again 4t of n by 4 plus 2n. Then again 2t of n by 8 plus n by 4 2n. This gives you final answer as 8t of n by 8 plus 3n. T of n is 2 power I, t of n by 2 power I plus in. That is nothing but 2 log 2n. That is n t of 1 plus n log n to base 2, n log n to the base 2 plus 2n. Merge sort. It sorts a given array by dividing it into two halves, sorting each of them recursively and then merging the two smaller sorted arrays into a single sorted one. 0 to n minus 1 and n by 2 minus 1 that is floor of n by 2 to n minus 1. Algorithm for merge sort a comma low comma high. If low is greater than high, return mid is equals to low plus high by 2. Merge sort of a comma low comma mid. Merge sort of a comma mid plus 1 comma high. Simple merge of a comma low comma mid comma high. That is algorithm of simple merge of a comma b comma c comma m comma n. Then we have I j k equals to 0. I is less than m, j less than n. We have a of I less than b of j, a of I less than b of j. Then c of k is a of I equals to I plus 1, k equals to k plus 1. C is the new array. If a of I less than b of j, then c of k equals to a of I plus 1, k plus 1. Otherwise, c of k is equals to b of j plus 1, k plus 1. And if and while, then while I less than m, c of k is a of I equals to I plus 1, k equals to k plus 1. While j less than n, c equals to c of k, p of j plus 1, k plus 1. And while either I or j exceeds its limits, the elements remaining in the other vector can be copied into the same vector c. Algorithm merge I low, j mid plus 1, k low, while I less than or equal to mid and j less than or equal to high. If a of I less than a of j, then c of k is a of I plus 1, k plus 1. The same thing is written in the form of low and high. I low, j is mid plus 1, k low. K is actually high.